October 19, 1943, 28,000 feet above the industrial haze of Schweinfurt, Germany. Oberleutnant Franz Stigler of WWII 27 had just watched something that violated every principle of aerial combat he'd learned in 4 years of war. An American P-47 Thunderbolt had taken a direct hit from a 20mm cannon shell. The round had torn through the fuselage just behind the cockpit, sending a spray of metal fragments glittering in the autumn sunlight. Stigler had seen this happen dozens of times before. The usual sequence was predictable: smoke, fire, the aircraft entering a terminal spin, and within seconds, the white blossom of a parachute as the pilot abandoned his dying machine. But this Thunderbolt didn't spin. It didn't catch fire. The massive radial engine continued its steady thunder, the propeller still clawing through the thin air at altitude. The pilot, whoever he was, maintained formation with his squadron, as if nothing had happened. Stigler radioed his wingman, his voice tight with disbelief. "Did you see that? The American is still flying." What Stigler couldn't know in that moment was that he'd just witnessed the beginning of a psychological campaign that would haunt the Luftwaffe for the remainder of the war. The Americans weren't just flying tough aircraft. They were flying aircraft that refused to die, machines that absorbed punishment no German fighter could survive, and returned home to fight again the next day. Within months, German pilots would develop an obsessive ritual that spoke to their growing desperation: counting parachutes. Every time they engaged American Thunderbolts, German pilots began tracking a grim arithmetic. How many parachutes appeared? How many Thunderbolts continued flying? The difference between those two numbers represented something the Luftwaffe had never encountered before: an opponent who could absorb catastrophic damage and keep fighting. This wasn't just durability, it was something closer to invincibility, and it was destroying German morale one engagement at a time. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The psychological impact of the P-47's legendary toughness didn't emerge overnight. It accumulated through hundreds of individual encounters, each one chipping away at German confidence, until what had once seemed like isolated incidents became recognized as systematic American advantages. The transformation in German attitudes toward the Thunderbolt occurred across a remarkably compressed time frame. From spring of 1943 through winter of 1944, and the change reflected a broader realization about American industrial and engineering capabilities that German propaganda had systematically understated. In April of 1943, when Thunderbolts first appeared in significant numbers over occupied Europe, German pilots felt genuinely confident. They flew aircraft like the Focke-Wulf 190 and Messerschmitt Bf 109 that represented the accumulated wisdom of years of combat experience. These were refined, battle-tested machines, flown by veterans who had fought across multiple theaters. The Americans, by contrast, appeared to be sending raw recruits into combat-flying aircraft that looked fundamentally wrong. The P-47 was enormous for a single-engine fighter, weighing over 7 tons when fully loaded. Its distinctive profile featured a massive Pratt & Whitney R 2800 double Wasp radial engine, housed in a cowling so large it gave the entire aircraft a portly, ungainly appearance. German pilots nicknamed it the Jugs, short for Juggernaut, though the term was initially used mockingly rather than respectfully. The aircraft seemed to embody American excess: too big, too heavy, too crude. Captain Hans Philipp, one of Germany's most decorated fighter pilots with over 200 victories, summarized the prevailing German attitude in a letter home dated April 26, 1943. He wrote, "The Americans have built a fighter that looks like it was designed by someone who had never seen air combat. It is fat where it should be thin, heavy where it should be light, and crude where it should be elegant. Our Focke-Wulfs will make short work of these flying barrels." Philipp's confidence reflected standard Luftwaffe doctrine that emphasized maneuverability, climb rate, and agility. German fighters were designed to excel in turning combat, where the pilot's skill and the aircraft's responsiveness determined victory. The Messerschmitt Bf 109 could outturn almost any Allied fighter at medium altitudes. The Focke-Wulf 190 rolled faster than anything in the sky and could sustain tight turns that would black out most pilots. These capabilities had served the Luftwaffe well against British Spitfires and Soviet fighters. German tactical doctrine emphasized gaining altitude advantage, diving to attack, then climbing away using superior power-to-weight ratios. If forced into a turning fight, German pilots could rely on their aircraft's superior maneuverability to gain position for a kill. The system had worked effectively for years, validated by impressive victory tallies accumulated by Germany's top pilots. The P-47 appeared to violate every principle of this proven doctrine. Its empty weight of 10,000 pounds exceeded that of some twin-engine aircraft. The massive radial engine, while powerful, seemed to sacrifice the streamlined efficiency that German designers prized. American pilots would later joke that the Thunderbolt didn't fly so much as beat the air into submission through sheer horsepower. German pilots, observing these lumbering machines struggle to altitude, felt certain their tactical advantages remained intact. The first serious engagements between Luftwaffe fighters and P-47 Thunderbolts occurred during April and May of 1943 as the U.S. 8th Air Force expanded its daylight bombing campaign against industrial targets in occupied Europe. These early encounters produced mixed results that confused German tactical analysts. Some Thunderbolts fell to German guns relatively easily, confirming expectations about the aircraft's supposed deficiencies. But other P-47 seconds absorbed damage that should have been catastrophic, yet continued fighting or limped home across hundreds of miles of hostile territory. Lieutenant Robert Johnson of the 56th Fighter Group participated in one of these early missions on April 13, 1943. His squadron was tasked with escorting B-17 bombers attacking industrial facilities near Bremen. German fighters intercepted the formation at 26,000 feet, and Johnson found himself engaged by a Focke-Wulf 190 flown by an experienced pilot who clearly understood deflection shooting. The German pilot's first burst struck Johnson's Thunderbolt in the right wing, tearing a hole approximately 2 feet in diameter through the aluminum skin. A 20mm explosive shell detonated inside the wing structure, destroying internal bracing and damaging the aileron control cables. Johnson felt the aircraft shudder violently as the shell exploded, and his first instinct was to prepare for bailout. Every fighter pilot had been trained that catastrophic wing damage meant the aircraft was finished, but the P-47 kept flying. The control stick felt heavier, and the aircraft wanted to roll right due to the damaged aileron, but Johnson discovered he could compensate by applying constant left pressure. The Thunderbolt's hydraulically boosted controls, though damaged, still functioned sufficiently for basic maneuvers. Johnson maintained formation with his squadron, completed the escort mission, and successfully landed at his base in England despite the massive hole in his wing. Ground crews who examined Johnson's aircraft after landing were genuinely stunned. The damage they documented was extensive. Destroyed wing structure, severed hydraulic lines that had somehow sealed themselves through fluid coagulation, and damage to the aileron control system that by all conventional engineering analysis should have rendered the aircraft uncontrollable. Yet Johnson had flown it for over 2 hours, including combat maneuvering and a normal landing approach. This incident circulated through the 56th Fighter Group as proof of the Thunderbolt's toughness. But more importantly, it began circulating through German intelligence networks as reports filtered back from Luftwaffe pilots who had witnessed the damaged aircraft continuing to fly. These early reports generated confusion among German tactical analysts. Had the pilot simply been lucky? Had German pilots overestimated the damage they'd inflicted? Or had the Americans actually built a fighter that could sustain battle damage no German aircraft could survive? The answer became clear through accumulated evidence over subsequent months. The P-47 possessed structural margins that exceeded anything in Luftwaffe service by substantial amounts. Republic Aviation's chief designer, Alexander Kartveli, had approached the P-47 project with explicit priorities that diverged from European fighter philosophy. Rather than optimizing for weight reduction and maneuverability, Kartveli emphasized pilot survival, systems redundancy, and structural overdesign that guaranteed the aircraft could complete its mission even after sustaining severe damage. The airframe structure incorporated safety factors that exceeded military specifications, where specifications required certain load limits. Cartvelli designed components to handle 50% higher loads. The wing spars were massively overbuilt compared to German practice. The fuselage structure incorporated redundant load paths, meaning that if one structural element failed, others could carry the load. Control systems included backup cables and redundant hydraulic lines. The engine installation exemplified this philosophy. The Pratt & Whitney R 2800 radial engine was mounted on a structure designed to absorb enormous forces. Behind the engine sat a firewall fabricated from stainless steel that could withstand direct hits from 20mm shells without penetrating into the cockpit. The oil cooler, radiator, and supercharger components were positioned strategically to protect vital systems, creating what amounted to armored zones through intelligent component placement rather than simply adding weight through armor plate. The pilot sat in the center of a protective cocoon. Armor plate behind the seat was 3/8 of an inch thick, sufficient to stop rifle-caliber bullets and shell fragments. Additional armor protected the pilot's head and sides. The cockpit floor incorporated armor that protected against ground fire during low-altitude operations. Bulletproof glass, 1.25 inches thick, protected the windscreen. The canopy framing was reinforced to prevent shattering under stress. Most critically, the fuel system incorporated features that dramatically improved survivability. The main fuel tanks were self-sealing, constructed with layers of rubber compounds that swelled when exposed to aviation fuel, automatically closing bullet holes and preventing catastrophic fuel loss. The fuel lines included check valves that would automatically seal if severed. The entire fuel system was designed to prevent fires even after sustaining multiple hits. Carbon dioxide fire suppression bottles could be activated to flood fuel tank spaces with inert gas. German fighters lacked many of these protective features. The Messerschmitt Bf 109 carried its main fuel tank directly in front of the pilot, separated from the cockpit by a thin metal bulkhead. A single incendiary bullet striking this tank often resulted in catastrophic fire that killed the pilot within seconds. The Focke-Wulf 190 was somewhat better protected, but still lacked the systematic redundancy and protection philosophy that characterized American design. By June of 1943, enough combat encounters had occurred that German intelligence officers began compiling systematic reports on P-47 durability. These reports, based on pilot debriefings and analysis of combat camera footage, documented disturbing patterns. Thunderbolts were returning to base with damage that would have destroyed any German fighter several times over. One report from WWII 26, dated June 7, 1943, documented an engagement where German pilots claimed 3 Thunderbolts destroyed based on observed hits. Combat camera footage showed clear strikes on all 3 aircraft, including what appeared to be catastrophic engine hits. Yet, American records indicated that all 3 P-47 seconds returned safely to England. German intelligence officers initially suspected American records were inaccurate or propagandistic. The alternative explanation was more troubling. The Thunderbolts were simply too tough to kill with conventional tactics. Lieutenant Hans Naumann of WWII 54 participated in an engagement on July 2, 1943, that convinced him the Americans had achieved something unprecedented in fighter design. His unit intercepted a formation of P-47 seconds, escorting bombers near Hanover. Naumann, flying a Focke-Wulf 190A6, achieved perfect firing position on a Thunderbolt, approaching from the classic 6 o'clock position slightly below, where the American pilot's visibility was most restricted. Naumann opened fire at 200 meters range, well within effective envelope for his 4 20mm cannons and 2 13mm machine guns. He fired a 3-second burst, which meant approximately 60 rounds of 20mm ammunition and over 100 13mm rounds. He observed strikes along the Thunderbolt's fuselage, saw pieces flying off the aircraft, and watched the left side of the cowling tear away, exposing the engine cylinders beneath. By all conventional combat experience, the American aircraft was finished. Naumann broke away to engage another target, confident he'd scored a kill. But 30 seconds later, his wingman radioed frantically. "The Thunderbolt you hit is still flying. It's chasing you." Naumann looked back to see the damaged P-47 pursuit, its cowling partially torn away, smoke streaming from the engine, but still maintaining formation speed and maneuvering aggressively. Naumann's after-action report reflected his disbelief. He wrote, "I scored definite hits with cannon fire at close range. I observed the strikes and saw substantial damage to the engine cowling. The aircraft should have been destroyed, or at minimum forced to withdraw immediately." Instead, the pilot continued, flying aggressively as if nothing had happened. "I cannot explain this. Either American pilots have remarkable courage to fly severely damaged aircraft, or these machines are far tougher than anything we have encountered." The reality was both. American pilots were indeed trained to push damaged aircraft to their limits, but more fundamentally, the P-47 was engineered to keep flying under circumstances that would have killed any other fighter. The massive R-2800 engine, with 18 cylinders arranged in 2 rows, could continue producing power even after several cylinders were destroyed. German inline engines, whether the Daimler-Benz DB series powering Messerschmitts or the BMW radials in Focke-Wulfs, were far more vulnerable to battle damage. A single hit on a coolant line meant engine failure within minutes as the system overheated. The R-2800, air-cooled and massively constructed, could lose multiple cylinders and still produce sufficient power to get home. Pilots discovered that even with 4 or 5 cylinders completely destroyed, the remaining 13 or 14 could generate enough thrust to maintain altitude and limp back to England. The engine's rugged construction meant that components rarely failed catastrophically. Damaged parts degraded gradually rather than failing suddenly, giving pilots time to assess damage and make controlled decisions rather than facing immediate catastrophic situations. By August of 1943, German pilots had begun developing the parachute counting ritual that would become emblematic of their psychological struggle against Thunderbolts. The practice emerged organically from multiple units independently, as pilots tried to make sense of engagements where they were certain they'd scored kills, but post-mission reconnaissance showed far fewer American losses than expected. The logic was straightforward. If you damaged an aircraft so severely that the pilot bailed out, you could be confident of the kill. A parachute represented incontrovertible evidence that the aircraft was destroyed and the pilot had abandoned it. But increasingly, German pilots observed situations where they scored obvious hits, watched pieces fly off American aircraft, yet saw no parachutes. Those Thunderbolts somehow continued flying, maintained formation, and disappeared into the distance heading west toward England and safety. Hauptmann Johannes Naumann of Jagdgeschwader, 26, explicitly described this practice in a letter to his brother dated August 23, 1943. He wrote, "We have developed a new way of assessing whether we have truly destroyed an American Thunderbolt. We count parachutes. If you see the white canopy, you know you got him. If the aircraft simply flies away despite being hit, you cannot be certain. These machines absorb damage that would destroy 3 Messerschmitts. The only reliable confirmation is watching the pilot jump." This parachute counting obsession reflected a deeper psychological transformation occurring throughout Luftwaffe fighter units during summer and fall of 1943. German pilots were confronting an uncomfortable reality. The Americans had solved problems that German engineers considered acceptable trade-offs. German design philosophy accepted vulnerability in exchange for performance. Pilots learned to fly carefully, to avoid damage, because their aircraft couldn't sustain much punishment. The American philosophy rejected that trade-off entirely. American designers had determined that getting pilots home alive mattered more than optimal maneuverability or minimal weight. They'd built an aircraft that could take horrific punishment and still complete its mission. This represented a fundamentally different approach to the fighter design problem, one that prioritized different values and reflected different assumptions about what made an effective weapon system. The Thunderbolt's combat debut in European skies had coincided with a broader American build-up that was beginning to demonstrate the full scope of U.S. industrial capacity. By fall of 1943, American bomber raids were growing in size and frequency. Each mission brought more bombers, more escorts, and replaced losses faster than the Luftwaffe could inflict them. German pilots found themselves facing not just tough aircraft, but seemingly inexhaustible numbers of them. Republic Aviation's production of P-47 seconds exemplified American industrial capabilities. The company's facility in Farmingdale, New York, employed thousands of workers organized along assembly line principles refined by automobile manufacturers. By late 1943, the factory was completing approximately one P-47 every hour during peak production periods. This output exceeded the total production of all German single-engine fighters combined during many months. Moreover, these American aircraft weren't crude or poorly made. Quality control maintained remarkably, tight tolerances across thousands of individual machines. Each engine received thorough testing before installation. Systems were checked, rechecked, and tested again. When P-47 seconds arrived at operational units in England, they were genuinely ready for combat, requiring minimal additional work beyond routine pre-flight inspections. German production, by contrast, was becoming increasingly chaotic during 1943. Allied bombing raids targeted aircraft factories, forcing dispersion of production into smaller facilities scattered across occupied territories. This dispersion reduced efficiency and complicated quality control. Many aircraft arrived at operational units requiring extensive additional work before they could fly combat missions. Spare parts shortages meant that damaged aircraft sat idle awaiting repairs. The psychological impact of facing an opponent with essentially unlimited resources and tough, reliable aircraft began manifesting in German pilot accounts and letters home during this period. References to American material superiority appeared with increasing frequency. Pilots described feeling overwhelmed not just by numbers, but by the quality and durability of American equipment. Lieutenant Gustav Freilinghaus of Jagdgeschwader II wrote in his diary on September 14, 1943, "We shot down 3 Thunderbolts today, confirmed by witnesses, but I personally put cannon shells into 5 others that I am certain I hit solidly. All 5 kept flying. One had smoke pouring from the engine, visible damage to the wing, and part of the tail surface missing. It maintained formation as if nothing happened. How do you fight an enemy whose aircraft refused to die?" If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The most famous incident illustrating P-47 durability occurred on June 26, 1943, and became legendary in both American and German aviation circles. Lieutenant Robert Johnson of the 56th Fighter Group's 61st Fighter Squadron had already survived one major combat-damaged incident in April. On this June mission escorting bombers attacking industrial targets near Paris, he would face something far worse. Johnson's flight encountered German fighters at approximately 27,000 feet. The engagement developed into a swirling, chaotic dogfight involving dozens of aircraft. Johnson damaged one Focke-Wulf and was maneuvering to engage another when he heard and felt impacts striking his aircraft. A Focke-Wulf 190 pilot had achieved firing position and was methodically shooting Johnson's Thunderbolt to pieces. The first burst shattered the canopy, filling the cockpit with wind blast and plexiglass fragments. Johnson couldn't see clearly through the shattered windscreen. The second burst struck the right wing, tearing large holes through the aluminum skin and damaging the aileron. The third burst hit the fuselage behind the cockpit, penetrating the structure and destroying hydraulic systems. Johnson tried to bail out, but discovered his canopy was jammed shut by damage. He was trapped in a disintegrating aircraft that was coming apart around him. The German pilot, whose identity remains uncertain, though some sources suggest it may have been Oberleutnant Egon Meyer, continued pressing his attack with methodical precision. Burst after burst struck the Thunderbolt. The elevator controls were hit. The rudder was damaged. More holes appeared in both wings. The engine cowling was partially torn away. Oil began streaming back over the windscreen, further reducing visibility. Johnson's aircraft had absorbed over 200 documented hits from 20mm cannon shells and 13mm machine gun rounds. By any conventional assessment, the aircraft was finished. No fighter could sustain that level of damage and remain flyable. Johnson should have been forced to bail out or should have gone down with his aircraft when it inevitably failed. But the P-47 kept flying. The engine, despite damage to cylinders and accessories, continued running. The control surfaces, though damaged, still responded to stick inputs. The structure, though riddled with holes, maintained its integrity. The German pilot apparently exhausted his ammunition attacking Johnson's Thunderbolt. According to multiple accounts, including Johnson's own post-war recollections, the Focke-Wulf pilot flew alongside the shattered P-47, close enough that Johnson could see him clearly. The German pilot looked at the catastrophic damage, looked at Johnson trapped in his cockpit, then did something extraordinary. He saluted, shook his head as if in disbelief, and peeled away, apparently unwilling to make a final ramming attack that would kill both pilots. Johnson nursed his destroyed Thunderbolt across over 200 miles of occupied France and the English Channel. The aircraft leaked oil continuously, forcing Johnson to carefully manage engine settings to avoid complete seizure. The damaged controls required constant attention and significant physical strength to maintain level flight. Visibility through the shattered canopy and oil-smeared windscreen was minimal. Johnson navigated by compass and dead reckoning, unable to clearly see landmarks below. When Johnson finally reached the English coast, he faced another crisis. His hydraulic systems were destroyed, meaning no landing gear, no flaps, and no brakes. He would have to belly land the aircraft, a procedure that carried significant risk of fire even for undamaged fighters. Johnson's Thunderbolt was so severely damaged that any impact might cause structural failure. Johnson executed a textbook belly landing at his base. The P-47 slid across the grass field, grinding along on its belly, scattering pieces as it decelerated. When it finally stopped, Johnson kicked out what remained of his canopy and climbed out onto the wing. Ground crews and squadron mates who ran to the aircraft stood in stunned silence. The Thunderbolt looked like it had been through an industrial shredder. Holes covered every surface. Major structural components were visibly damaged or missing. The engine was barely recognizable beneath the torn cowling. Aircraft recovery specialists counted over 200 impact points on the airframe. Multiple 20mm shells had detonated inside the fuselage. 13mm rounds had punched through wings, tail surfaces, and control systems. Critical structural members showed damage that should have caused catastrophic failure. Yet somehow, the aircraft had held together long enough to get Johnson home. Republic Aviation later requested that Johnson's aircraft be shipped back to the United States for detailed examination by engineers. They wanted to understand precisely how the P-47's structure had sustained such damage without failing, to identify what design features had been most critical to survival, and to determine if additional improvements could enhance durability even further. The aircraft, serial number 42 to 8487, was carefully disassembled and studied exhaustively. Engineers discovered that multiple design features had contributed to survival. The wing structure's redundant spars meant that damage to one primary structural member could be absorbed by others. The control cable routing included enough redundancy that even with several cables severed, some control authority remained. The engine mounting structure had contained damage that would have propagated catastrophically in less robust designs. Most critically, the fundamental over-design philosophy, building every component stronger than strictly necessary, had created survival margins that made the difference between destruction and survival. Johnson's survival became legendary among Thunderbolt pilots and represented a watershed moment in German perceptions. Word of the incident spread quickly through Luftwaffe units via multiple channels. German pilots who had witnessed the damaged aircraft limping west intelligence reports based on radio intercepts, and eventually through interrogations of captured American pilots who recounted the story. For German pilots, the incident confirmed what many were beginning to suspect. The Thunderbolts were essentially unkillable through conventional means. Oberleutnant Heinz Nock of Jagdgeschwader 11 wrote in his memoir about the psychological impact of stories like Johnson's survival. He noted, "We heard accounts of American pilots flying aircraft so badly damaged they should have fallen from the sky, yet somehow reaching England and safety. At first, we dismissed these as propaganda or exaggeration. But as more reports accumulated, we realized the Americans had built something entirely new. These were not fighters in the traditional sense. They were flying fortresses designed to protect their pilots at all costs." The autumn of 1943 marked a turning point in German tactical discussions about engaging American fighters. Luftwaffe units across occupied Europe began sharing information about Thunderbolt durability through formal intelligence channels and informal pilot networks. What emerged was a disturbing pattern that contradicted years of combat experience and established doctrine. Traditional fighter combat doctrine, as practiced by all major air forces since World War I, relied on certain fundamental assumptions. A well-placed burst of cannon or machine gun fire into critical areas' engine, cockpit, fuel system would disable or destroy an enemy aircraft. Pilots trained extensively to achieve proper deflection angles and firing solutions that would place rounds into these vulnerable zones. The system worked because aircraft were inherently fragile machines. Aluminum skin tore easily, control cables severed, engines failed when damaged, fuel tanks exploded when hit by incendiary rounds. The P-47 violated these assumptions systematically. Its engine didn't quit when hit. Its fuel tanks didn't explode. Its structure didn't fail even when riddled with holes. German pilots found themselves in the psychologically destabilizing position of executing perfect attacks, achieving solid hits, yet watching their targets continue flying as if nothing had happened. This undermined confidence in tactics, weapons, and ultimately in the possibility of victory itself. Major Günther Rahl, who would end the war with 275 confirmed victories, third highest total among German pilots, participated in numerous engagements against Thunderbolts during late 1943. His assessment, recorded in post-war interviews, captured the frustration German pilots felt. The P-47 was a pilot's aircraft in the best American tradition. It was rugged, reliable, and forgiving. You could hit it repeatedly, and it would keep flying. Our fighters were high-performance machines, but they were also fragile. A few good hits, and we were finished. The Americans could absorb damage that would destroy 3 or 4 of our aircraft and still make it home. Rahl's observation highlighted another dimension of the durability problem that extended beyond individual combat encounters. Even when German pilots succeeded in damaging Thunderbolts severely enough to force them out of combat, these aircraft often made it back to England. Damaged P-47 seconds, limping home across hundreds of miles of hostile territory, became an increasingly common sight during late 1943. British observers along the coast reported seeing Thunderbolts crossing the channel trailing smoke, with visible battle damage, flying on partial power, yet still maintaining enough altitude and speed to reach their bases. This survivability translated directly into pilot survival, which in turn meant that American fighter pilots gained combat experience at rates German pilots could not match. A Luftwaffe pilot whose aircraft was seriously damaged faced significant probability of death or capture. The fragility of German fighters meant that battle damage often proved fatal before the pilot could bail out. Even successful bailouts over German-controlled territory didn't guarantee survival, as parachute landings carried injury risks, and there was no guarantee of quick rescue. American pilots in Thunderbolts could sustain serious damage and still fly home. This meant they survived to fly again, accumulating combat experience and tactical knowledge that made them progressively more dangerous opponents. By fall of 1943, veteran American pilots with 10 or 20 missions had learned the Thunderbolt's capabilities intimately and understood how to exploit them tactically. These veterans formed a core of experienced pilots who could mentor newcomers, passing along hard-won tactical knowledge. The German pilot training pipeline, by contrast, was beginning to show severe strain by late 1943. Fuel shortages increasingly limited training hours. Experienced pilots who could have served as instructors were desperately needed at the front to face growing Allied pressure. New pilots arrived at operational units with minimal training, often less than 100 hours total flight time. These inadequately prepared pilots faced experienced Americans flying superior aircraft, a combination that produced predictable and tragic results. Luftwaffe loss rates among new pilots were catastrophic during this period. Many survived only a handful of missions before being shot down. The veterans who might have protected them were being ground down through relentless attrition. Meanwhile, the Americans were building a cadre of highly experienced fighter pilots who understood both their aircraft and effective tactics for using them. The P-47's durability was a critical enabling factor in this American advantage, keeping pilots alive long enough to become veterans. German intelligence officers recognized these trends and attempted to develop tactical recommendations that would improve German pilots' odds against Thunderbolts. Reports circulated through Luftwaffe channels during October and November of 1943, containing detailed analysis of P-47 capabilities and suggested counter-tactics. These reports reflected both professional competence in intelligence gathering and growing desperation, as officers struggled to find effective solutions to a worsening problem. Krupinski's combat report documented the results, observed multiple strikes on target aircraft's fuselage and left wing, saw pieces of cowling separate from engine, continued firing until ammunition exhausted. Target aircraft rolled inverted, appeared to lose altitude, then recovered and maintained formation. No parachute observed. Assessment. Damage inflicted, but aircraft remained operational. This represented precisely the outcome German intelligence had warned about. Krupinski had followed tactical guidance perfectly. Close range, sustained fire, ammunition exhausted attempting to ensure kill. Yet the Thunderbolt survived. The psychological impact on Krupinski and pilots like him was severe. If perfect execution of recommended tactics still couldn't guarantee kills, what could they do? The parachute counting ritual that had emerged during summer of 1943 became increasingly formalized during fall and winter, as German pilots sought some reliable metric for assessing combat effectiveness. Official kill confirmation procedures required either visual observation of the aircraft's destruction, witness confirmation from other pilots, or evidence like gun camera footage or wreckage location. But these standard confirmation methods broke down when facing Thunderbolts. Aircraft that appeared destroyed through visual observation turned out to have survived and made it home. Witness confirmation became unreliable because multiple pilots might observe the same damaged aircraft and all claim credit, only to discover later that it had survived. Gun camera footage showed hits, but couldn't prove whether the damage was ultimately fatal. Wreckage was rarely found because damaged P-47 seconds typically flew far enough west before any potential crash that they came down in Allied-held territory or the English Channel. Parachutes represented the only truly reliable confirmation. If you saw a white canopy blossom beneath a Thunderbolt, you knew conclusively that the pilot had abandoned his aircraft and it was genuinely destroyed. This created a perverse situation where German pilots were almost rooting for pilots to bail out, not from any particular malice toward individuals, but simply from desire for confirmation that their attacks had actually achieved results. Hauptmann Wilhelm Herget of WWII 4 explicitly described this phenomenon in a letter to his parents dated December 3, 1943. Today I engaged an American Thunderbolt and saw my rounds striking all over his aircraft. Smoke poured from the engine. The tail looked damaged. I was certain he was finished. But he kept flying and eventually disappeared into clouds heading west. I claimed a probable kill, but I cannot be certain. Unless you see the parachute, you never really know with these machines. It is deeply frustrating to fight an enemy that refuses to die. This frustration was compounded by the administrative consequences of uncertain kill confirmation. German pilots received official credit for victories only when kills could be confirmed through established procedures. Probable kills and damaged aircraft didn't count toward official scores. For pilots in a military culture that heavily emphasized victory tallies and awarded decorations based on confirmed kills, the inability to reliably confirm Thunderbolt kills was professionally frustrating beyond tactical implications. The contrast with earlier periods of the war was stark. When fighting Soviet fighters during 1941 and 42, German pilots achieved spectacular victory ratios, partly because Soviet aircraft were relatively fragile and tended to explode or break apart when hit. Confirmations were easy. Fighting British Spitfires was more challenging, but the Spitfire's limited fuel capacity meant damaged aircraft often couldn't make it home across the Channel, and crashed aircraft could sometimes be located by ground observation. The Thunderbolt changed everything. It could absorb damage that would destroy other fighters and still fly home across enormous distances. German pilots found themselves in the psychologically corrosive position of achieving tactical success, scoring hits, damaging enemy aircraft without being able to definitively confirm strategic success through confirmed kills. This uncertainty undermined confidence and morale progressively over time. By December of 1943, German fighter pilot accounts and unit records showed unmistakable signs of this psychological erosion. References to American material superiority appeared with increasing frequency. Pilots described feeling overwhelmed not just by numbers, but by the quality and durability of American equipment. The confident tone that had characterized earlier reports gave way to frustration, anxiety, and growing recognition that the tactical situation was deteriorating. The winter of 1943 through 1944 brought several developments that further worsened the German position against Thunderbolts. American tactical doctrine evolved as US. Pilots accumulated experience and developed techniques that fully exploited the P-47's strengths while minimizing its weaknesses. Meanwhile, technical improvements to the Thunderbolt addressed some of its initial limitations, creating an even more formidable opponent. American fighter tactics during early 1943 had been relatively unsophisticated, based primarily on pre-war doctrine that didn't fully account for the unique characteristics of the aircraft available or the specific tactical situation in the European theatre. But by fall of 1943, experienced squadron and group commanders had developed tactics specifically optimized for the P-47's capabilities. The key insight was recognizing that the Thunderbolt should not fight like a European fighter, emphasizing turn performance. Instead, it should fight like an American fighter, emphasizing speed, altitude, and energy management. Lieutenant Colonel Hubert Zemke, commanding the 56th Fighter Group, pioneered many of these tactical innovations and disseminated them through the 8th Air Force fighter groups. Zemke's tactics emphasized maintaining speed and altitude advantage whenever possible. P-47 formations would climb to 30,000 feet or higher before entering combat zones, altitudes where the Thunderbolt's turbo-supercharged engine maintained excellent power, while German fighters' single-stage superchargers struggled. From this altitude advantage, American pilots could dictate engagement terms, diving to attack when conditions favored them, then climbing away using superior power and zoom climb performance. When German fighters attempted to engage, Thunderbolt pilots avoided sustained turning combat, where the lighter German fighters held advantages. Instead, they used boom and zoom tactics, diving at high speed, making a single firing pass, then extending away at full throttle before German pilots could react effectively. The P-47's superior speed and dive performance meant that German fighters couldn't catch Thunderbolts that chose to disengage. If German pilots tried to follow through dives, the Americans could simply accelerate away. These tactics transformed the P-47 from a fighter trying to compete on German terms into a fighter imposing its own terms on combat. German pilots found themselves unable to force engagement on favorable conditions. Fast-moving Thunderbolts diving from altitude appeared without warning, fired devastating bursts from their 850 caliber machine guns, then disappeared before effective counterattacks could be mounted. Attempts to pursue were futile. The Thunderbolts were simply too fast. Technical improvements to the P-47 during late 1943 further enhanced its capabilities. The introduction of paddle blade propellers on the P-47D model improved rate of climb significantly, addressing one of the aircraft's few genuine weaknesses. The new propellers featured broader blade tips that increased thrust, allowing faster acceleration and better climb performance. Thunderbolts equipped with paddle blade propellers could climb to combat altitude faster and could better maintain energy during vertical maneuvers. Water injection systems provided emergency power for critical situations. By injecting a water-methanol mixture into the engine during takeoff or combat, pilots could temporarily boost power output to over 2,300 horsepower, a substantial increase over normal military power settings. This emergency power allowed Thunderbolts to out-accelerate virtually any opponent for short periods, providing critical advantages during defensive situations or when catching German fighters attempting to escape. Improved gun sights enhanced firing accuracy. The K-14 gyroscopic gun sight, introduced during late 1943, automatically computed deflection angles based on target range and angular rate, significantly improving hit probability even for average pilots. German pilots noticed that American marksmanship seemed to improve dramatically during this period, with more rounds actually hitting targets. The improved gun sights were a major factor, allowing pilots to achieve effective hits without requiring the extensive experience and natural aptitude that deflection shooting traditionally demanded. These technical and tactical improvements arrived simultaneously with increasing numbers of P-47 seconds in the European theatre. By January 1944, the 8th Air Force could field over 250 Thunderbolts on major missions, providing overwhelming escort coverage for bomber formations. German fighters faced not just tough, well-flown aircraft, but enormous numbers of them operating with tactical sophistication that maximized their inherent advantages. The psychological pressure on German pilots intensified correspondingly. Major Heinz Bahr of WWII, an accomplished pilot with over 200 victories, described the situation in January 1944. "We are outnumbered 5-1, or worse. The American pilots are well-trained and fly excellent tactics. Their aircraft are fast, tough, and heavily armed. When we engage, we must achieve kills quickly or risk being overwhelmed by their numbers. But their Thunderbolts don't die easily. You can hit them repeatedly, and they keep flying. Meanwhile, one good burst and our aircraft are finished. The mathematics of attrition are entirely against us." Bahr's assessment captured the multiple dimensions of German disadvantage converging simultaneously. Numerical inferiority alone would have been challenging, but potentially manageable through superior tactics or aircraft performance. But German pilots faced numerical inferiority while also flying aircraft that were more vulnerable, with less experienced pilots, against an enemy whose material advantages were becoming overwhelming. The parachute counting phenomenon reached its peak during early 1944, as German pilots sought any reliable indicator of actual success against Thunderbolts. Unit intelligence officers began including parachute observations in standard combat report forms. Pilots were explicitly instructed to note whether they observed parachutes during engagements, recognizing that this represented the most reliable confirmation available. This systematic documentation revealed disturbing patterns. Analysis of combat reports from January through March 1944 showed that German pilots observed far fewer parachutes than they claimed aircraft damaged or destroyed. In typical engagements, pilots might report 10 to 15 Thunderbolts damaged with visible hits, but observe only 2 or 3 parachutes. The implication was clear. The vast majority of damaged P-47 seconds were surviving and returning home. Oberst Johannes Steinhoff, a respected fighter leader commanding Jagdgeschwader 77, attempted to address this problem through improved gunnery training during early 1944. He organized special training sessions focused on achieving very close firing range and concentrating fire on specific vulnerable points. His pilots practiced attacks against ground targets to improve accuracy, then attempted to apply these techniques in combat. The results were modest at best. Steinhoff's pilots achieved somewhat higher kill rates against Thunderbolts compared to units without special training, but the fundamental problem remained. Even with improved marksmanship and optimal tactics, the P-47 was simply too durable to kill reliably unless conditions were perfect. Steinhoff's after-action reports from March 1944 reflected his frustration. Our pilots are executing attacks correctly and achieving hits. The problem is not pilot skill or tactics. The problem is that American aircraft are built to survive damage that would destroy ours. Until we have aircraft with comparable durability or weapons with much greater destructive power, we will continue facing this challenge. Steinhoff had identified the core issue accurately. The problem wasn't tactical or even primarily about pilot quality. It was fundamentally about aircraft design, philosophy, and the industrial capacity to implement that philosophy in mass production. The Americans had chosen to build fighters that prioritized pilot survival and mission completion over absolute performance optimization. This choice reflected not just different engineering preferences, but different strategic calculations about what made an effective air force. American planners understood that aircraft could be replaced far more easily than trained pilots. Investing in aircraft durability paid strategic dividends by preserving the most valuable and irreplaceable resource: experienced combat pilots. German planners had made different choices, prioritizing maximum performance, even if that meant reduced survivability, reflecting assumptions about pilot supply that proved incorrect as the war progressed and attrition decimated the ranks of experienced pilots. By spring of 1944, as Allied preparations for the invasion of France intensified, German fighter units faced their worst situation yet. American fighter escorts, primarily P-47 seconds, increasingly P-51 Mustangs, provided comprehensive coverage for bomber formations throughout their missions. German pilots could no longer wait for escorts to reach fuel limits and turn back before attacking bombers. Every interception meant fighting through screens of superior Allied fighters. The parachute-counting ritual that had begun as an informal practice became a grim necessity for maintaining any realistic assessment of combat effectiveness. German intelligence officers privately acknowledged that official victory claims were substantially inflated, not through pilot dishonesty, but because damaged aircraft that should have been destroyed were somehow making it home. Parachute observations provided the only truly reliable metric, and those numbers painted a devastating picture of German ineffectiveness against Thunderbolts. General Lieutenant Adolf Galland, the General der Jagdflieger responsible for all Luftwaffe fighter operations, confronted these realities during spring 1944. His position gave him access to comprehensive intelligence from all fighter units, allowing him to see patterns that individual pilots or unit commanders might miss. What he saw alarmed him deeply. Galland commissioned a detailed study of combat effectiveness against American fighters during March and April 1944. The analysis examined hundreds of combat reports, compared German claims against Allied loss records, and attempted to establish reliable kill ratios. The results were sobering. When using parachute observations as confirmation standard, German kill ratios against P-47 seconds were approximately 1-to-1, meaning German fighters were being lost at roughly the same rate they destroyed Thunderbolts. Traditional victory claims suggested ratios closer to 3-to-1 in Germany's favor, but these claims couldn't be substantiated. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.